Whenever you come across a function, whatever kind of function it is, you should always think about what's the domain of that function, and because of that, is there any issues that limit the domain? So always think about that when we're looking at any of these functions that we're going to be looking at. So functions have a new type of arithmetic. We of course have addition, subtraction, multiplication, division of functions, which I'll show you. But functions also have something called composition. And, and that's really just plugging one function into another function. That's what composition means. It's going to look like this, where you have f of x composed of g of x, but this is the same thing as just saying f of g of x. So we're going to plug g of x, plug the second thing into the first thing, plug the inner thing into the outer thing. Well, here we have these two functions. This is a polynomial, so we know it has no issues in the domain. That's the nice thing about polynomial functions. This one here, well, we have a couple, really one issue. This is a fraction, and we cannot have 0 in the denominator. There's no other issues because the top is a polynomial. The bottom is an absolute value, and absolute value didn't have any issues. You can take the absolute value of any number. It just becomes the positive version of it. And for a division, we cannot have x equal to 0. So we know it's going to be everything in the domain for g of x except for x equal to 0. Okay, now let's go ahead and plug this thing in and see what happens. So we're going to take g of x, because it's on the inside, we're going to plug this function into the other function. So we're going to have f of 3x plus 1 over 2 times the absolute value of x. So this is going to get plugged into the input of all of these things. So we have, this is x, we have an input here and an input there. So all those become this thing. That's going to be 5 times 3x plus 1 over 2 times the absolute value of x plus 2 times 3x plus 1 over 2 times the absolute value of x squared. Okay, we can simplify the statement down. I'm going to write it like this. I'm going to distribute the 5 onto the top. You get 15x plus 5 over 2 times absolute value of x plus, this thing needs to be squared, so we're going to get 2 times. It's actually an interesting question because whenever you square anything, you always get the positive version. So the absolute value of x times the absolute value of x, you could say the absolute value of x squared, but as a result of this, it doesn't really matter if you get a negative on the outside or not, because when you square anything, it always becomes positive. It doesn't matter if it's negative or positive that you plugged in. So really, this is really the same thing as x squared, because it doesn't change any meaning of what we're looking at. It's not really necessary to do anything about it yet because we actually have 2 different fractions and want to combine them. So we're going to multiply this one by 2 absolute value of x, 2 absolute value of x. That's going to give us, and nothing really simplifies here. The absolute value of x kind of limits what we're looking at. If you're to look at portions of the domain, for instance, when x is positive, you could remove the absolute value and then you could combine like terms and everything, but you're limiting your domain at this point. The domain of this one is still the everything except for 0. That's the big issue here. So we're just going to leave it like this. Okay, now, and if instead we're looking at g of f of x, that's the same thing as plugging f into g. So we're going to get g of f was that. Now we can do 3 times 5x plus 2x squared plus 1 over 2 times the absolute value of 5x plus 2x squared. And in this case, we have 15x plus 10x squared plus 1 over, this can be negative if x is negative, like so what I want to do is I want to look at this bottom thing here and see if it can be negative, because if it cannot be negative, then the absolute values don't actually add anything here, and potentially we could maybe reduce anything. Probably not, but maybe. Well, if you look at this bit in the bottom inside the absolute value, we're just asking, can it ever be negative? Well, a good way to do that is think of it as its own function. It's a polynomial, and it's a quadratic specifically, since x squared is the highest power, so that it's the degree 2. And graphing this thing, we get this, and you can see it does in fact become negative only for this limited portion of the domain. What that means is that we cannot remove the absolute value, since it will change these values here whenever x is in this portion. So we have to leave the absolute value in, and that means we cannot really simplify this down any further. So that's what we get. Of course, we can ask, well, when is this thing 0? Well, it's 0 when the denominator equals 0. The denominator equals 0 when the inside bit here, this function, equals 0. And that equals 0, well, right there at the x-intercepts, the zeros of this quadratic, negative 2.5 and 0. So we know that this thing, x cannot equal negative 2.5 or 0. And this is an important idea, is that when we compose these two functions together, the domain of the new function actually is different than these two functions. So you have to constantly keep in mind that whenever you do any kind of arithmetic on a function, you can actually change the domain. In general, every single of the basic arithmetic that we can do on functions. So we're going to have f of x be a quadratic, 4 minus x squared, and g of x be this linear function, 2x minus 4. So let's go ahead and do the arithmetic and find their domains. So f of x is just 4 minus x squared. G of x is 2x minus 4. If we add them together, we get, let's see, negative x squared plus 2x, the negative 4 and the plus 4 cancel. This is just a quadratic function. It's a polynomial. Therefore, its domain is everything. So nothing changed there. Subtraction, f of x minus g of x. Now I'm going to put g of x in parentheses so I can distribute this negative. That's going to give me 4 minus x squared minus 2x plus 4, which now gives me negative 2x, or negative x squared minus 2x plus 8. Once again, a quadratic function, which is a polynomial, and polynomials have everything in their domain. Okay, f times g of x is going to be 4 minus x squared times 2x minus 4. Filling this thing out, we're going to distribute this, distribute that. That's going to be 8x minus 16 minus 2x cubed plus 4x squared. Rewriting this in standard form, highest degree to lowest, or highest power to lowest power. You can see that this is a cubic function. It's just a polynomial. That means its domain is everything. Finally, we have division. F of x is, let's see, 4 minus x squared. G of x is 2x minus 4. At this point, you notice, well, we have an issue potentially when we divide by 0. And that happens at positive 2, right? 2 times 2 is 4, minus 4 is 0. So x cannot equal positive 2. This, however, can be simplified, I believe. This is a difference of 2 squares on top. 2 minus x, 2 plus x it can factor down into. On the bottom, I can take out a 2. And I can rewrite this thing on top by taking out a negative. Take out a negative, I get x minus 2, 2 plus x. I just took out a negative. I factored out a negative from the top, and that gave me x minus 2, and those cancel. And so we get negative 2 plus x over 2. So I can write like this. Okay, and it's important to note here that even though this portion has no issues in the domain, the thing that we started with did. So we must exclude this, even though this there's 2 is fine in this one, right? 2 plus 2 is 4. Negative 4 over 2, that's going to be negative 2. There's no issues plugging in 2 into this one. There was, however, an issue plugging it into the original stated function. All this is a simplification from this statement. So you have to think of this as the original function. So our domain changed once again. These things had everything in the domain. All the previous ones, everything in the domain. This one now has everything but 2. That's the domain for this last function. Okay, now let's go ahead and compose them each way. So f of g of x and g of f of x. Okay, so f of g of x means you're going to plug g into f. You don't have to actually write this thing out every single time. I'm just doing it for the sake of clarity. 4 minus x, which is now 2x minus 4. And then that's going to be squared. Okay, I can simplify this by expanding this thing out. And distributing the negative. And now I can combine like terms. Okay, this is just a quadratic function. Its domain is everything. No issues with that one. Going the other way, this of course is g of f of x. So we can just plug in f of x into g of x. That's going to give us 2 times f of x minus 4. Distribute the 2. And simplify. Once again, a quadratic function. Its domain is everything. Now, let's look at different kinds of functions. This is the square root of 11x plus 1, and g of x is 1 over 2 minus x. Same process, find the following functions in the domain. Of course, we're also going to do the composition there. So let's go ahead and find that. Okay, f plus g is going to be the square root of 11x plus 1 plus 1 over 2 minus x. And really, this doesn't simplify at all further. We know that f of x has a limited domain because we cannot have negative numbers underneath of it. So we cannot have, or I should say, anything less than x must be greater than or equal to negative 1 over 11. Because negative 1 over 11 times 11 is negative 1. Negative 1 plus 1 is 0. If you do anything less than that, for instance, negative 1 times 11 is negative 11, plus 1 is negative 10. And that's a complex number, which we are not allowing in our domain because we cannot graph complex numbers. So x must be greater than or equal to negative 1 over 11. And this portion says that x cannot equal positive 2. That gives us 0 in this denominator. So we have both of these things we have to look at, consider. So this one says that we must have something like this. However, we must remove 2 from this because 2 is in this domain. So This one's actually going to be to 2 union with 2 to infinity. That's the full domain for f of x plus g of x. Likewise, f of x minus g of x, well, this is the same thing with a subtraction now. That didn't change anything. There's not really much we can do to simplify. We still have this restriction. X must be greater than or equal to negative 1 over 11. And x cannot equal negative 2. So the domain is the same. Okay, multiplying them together, we're going to get the square root of 11x plus 1 times 1 over 2 minus x. Well, that just goes on top. This really can't simplify it all further because the square root contains everything on the inside there, and there's nothing really we can do. This also has the same issues. We can't have a negative underneath the square root, and we cannot have 0 in denominator. So the same domain for this one as well. Okay, for division, we're going to get the square root of 11x plus 1 over 1 over 2 minus x. Now this one, we can actually flip this. We still have to think that, well, x cannot equal 2 because this has a denominator of that could be 0 here if we did that. But we can multiply by the reciprocal. And that's just going to give us this function here. Not really much we can do to simplify it. This one doesn't look like there's any issues with the domain being 2, but there is inherently an issue from this original statement. So when we do this, that we're going to have the exact same domain that we've had before. Okay, now let's look at the composition. Okay, let's go ahead and compose these two functions. G of x is going to be plugged into f of x, so we're going to get that's going to be 11 times 1 over 2 minus x plus 1 and the square root of that. And we're asking, when is the inside give us a negative number? Well, we also have a fraction here, so we know x cannot equal 2. But the inside thing gives us a 0 when that equals 0, when the inside bit. So subtract 1. Multiply by 2 minus x. That's going to give us 11 equals negative 2 plus x. So all we have to do is add 2. X equals 13. So 13 is going to give us, 0. So x cannot be, what can be 13, the right 0 is fine underneath of the square root. The square root of 0 is 0. The question is, can it be greater than 13 or is it going to be less than 13? For that, well, we can actually just test the value. Like, for instance, let's test for 14, just one greater. So 14 minus 2 is negative 12. 1 over negative 12. 11 over negative 12 becomes negative 11 over 12. Negative 11 over 12 plus 1, that's just going to be 1/12, positive 1/12. So no issues there. That's when we tested 14. So x equal to 14 worked. Let's try x equal to 12. It's 1 over 2 minus 12, so it's going to be 1 over negative 10. 11 times negative 1/10. It's going to be negative 11/10, which is bigger than negative 1. And when you add that together, you're going to get underneath the denominator, you're going to get, or underneath the radical, you're going to get negative 1/12. And negative 1/12 does not work. So we know that x equal to 12 does not work. We can't allow it. So that means that x must be greater than or equal to 13. And x cannot equal 2. But if x is greater than or equal to 13, already x can't equal 2. So there's no issue with that. So the domain of this function is going to be 13 on up. Okay, lastly, we're going to do g of f of x. We're going to plug f of x into g of x. That's going to give us 1 over 2 minus the square root of 11x plus 1. And now we ask the same question. Well, what are the issues? Well, we know that once again, x has to be greater than or equal to negative 1 over 11, because that's going to give us 0 in the denominator, or 0 underneath the radical. And then if x is greater than that, 0, we're going to get a positive number. Okay, so also we have a denominator that can be equal to 0. So we must ask the question, when is 2 minus the square root of 11x plus 1 equal to 0? Well, we can add the square root over to the other side. To solve this radical equation, we just need to square both sides. Now we can subtract 1 and divide by 11. So this is when we get 0. Let's just test that. 3 over 11 times 11 is 3. 3 plus 1 is 4. The square root of 4 is 2. And 2 minus 2 is 0. So x cannot equal 3 over 11. 3 over 11 is in this domain range. So the domain is going to be negative 1 to 11 up to 3 over 11, 3 over 11 up to infinity. We have to remove 3 over 11 from that, from this domain. Okay, hopefully that made sense. And I want you to give it a try in number 4.